Now, with this one, we can use calculus to help us to sketch curves. Alright, so we can use calculus to sketch almost any graph.
Almost.
Yeah, because like once they go above certain powers, they become really hard. Almost any curve. Okay. Now the idea behind this topic is that we have certain features that we need to be aware of, and before we begin the actual curve sketching, we need to observe certain behaviors of the tangent. Okay, so let's have a look at what I'm talking about. The sign of the derivative is what we're going to look at. The sign of the derivative helps us to determine the nature of parts of a curve. Okay?
What?
Parts, sections.
No.
The sign of the derivative helps us to determine the nature of parts of a curve. So what we need to do before we begin anything is just understand what we're dealing with here. So let me do a random graph. And what I want you guys to do is define or tell me the gradient values that we could possibly have. Hey, you're knocking the table. Okay. So here's a graph, guys. Wait. Stop. There's a graph. Now, what I want you guys to help me with is tell me certain gradient sections, like tell me the behavior and give me an approximation of a value you might think it could take. Alright, so let's start over here. Whoa, what happened there? I don't know. It's my tablet, I can do whatever I want. Now, well, right there,
What'd you do, sir?
what kind of tangent would I have here? What would dy dx be here? That's the real question. Dy dx.
Negative.
Well,
Guessing.
which way is the gradient going to run here?
Is it running that way?
Hey, that way.
Yeah, so is that positive, negative, zero?
Negative.
That's negative?
Positive.
It's increasing from left to right. It's going up. It's going up a hill, Shady. Up.
Yes,
Was
Shadi,
it
man.
That was Zach.
Alright,
Shut the
look.
heck up, no, it wasn't.
Zach the other side.
Boys, watch. Ugh. Yeah, give me one.
There's a roadblock.
It works. Alright, I think there's a line tool on this, like a straight line tool, but I haven't found it yet. Anyway, that there, this gradient is positive. Oh, whoops. Now that could be 1, 2, 3, it could be a fraction, but right there we know that it's a positive gradient, correct? Okay. Now, what do you think the gradient, oh my god, what do you think the gradient here is? Zero, very good. Someone said neutral as well, good word. How do you speak two words at once? Alright, so here we go. Here, the gradient is 0. So dy dx is exactly 0. That means it's a 0 tangent or a 0 gradient. Got it? Now, what about the gradient here? That's a negative gradient, correct. That there is a negative tangent. So here, dy dx would be what? Less than 0. Okay, now guys, do you notice something in this little section here? I have increase, then I have flat. Whoops, wait, hold on, let me do it in line. I have an increase, flat, and then a decrease. Boys, don't make me correct you on the video, come on, that's stupid. Alright, look at that. We have an increase, flat, and a decrease. So, what kind of turning point is that? Use any words you can think of. 90 degrees. What kind of turning point is that?
Drop. Crest.
Someone who's not in year 12.
Up, flat, down.
Guys, what is it? Upside down?
No, it says up, flat, down.
Curved down, yes. Another way to say that is concave down.
That's the
No,
one.
don't you dare say circle in this. This is not a circle.
Chris.
Don't say circle.
Trapezium.
Triangle.
Triangle, this is going. Go back to kindergarten. Now, guys, this is called a maximum turning point.
Oh, yeah.
This is called a maximum turning point.
Oh, we done this.
That was the first one I said, but
I don't know what you said, Jason.
Well,
Maximum
that's two words.
turning point. Alright, guys, I need quiet, come on. Alright, so that's a maximum turning point right there. What do you think the other one's going to be? Obviously, but
Nah, is it?
you need to understand the dy dx's around the turning point. Okay? So here, what would dy dx be here?
positive.
Come on, man. Think of lines, linear function. Negative. So dy dx is less than 0. Boys. Adam, come on. dy dx here is 0. Sorry, less than 0. What about here? What's dy dx? That's exactly 0. What about here? What's the gradient here? That's positive. So that's dy dx is greater than 0. So look at that. Less than 0. Yeah, maximum turning point. Less than 0. 0. And then greater than 0. Let me just move this down because I need more room. What kind of turning point is that?
Minimum.
That is a minimum turning point. Correct. And look at that. Minimum turning point. Okay? Does that make sense, guys? Alright, excellent. So long as these are the key features that we need to understand surrounding the turning points of a graph. And these are actually what help you to conclusively find what a graph looks like. If you can find the turning points and their positions, that's it. Exactly. Like for example, if I say this, if I say 3, 4 is a minimum, yeah, and then I say 7. Wait, it should be higher or lower? Minimum, higher. If I say 7, 8 is a maximum, if I do an XY plane, 3, 4 is here, and 7, 8 is here. If I know this is a minimum, I know it's doing that. If I know that's a maximum, I know it's doing that. Do I know what the graph looks like? 100%. I just connect it like a dot to dot. That goes up, that goes down. Make sense? That's the power of calculus. It allows you to fully sketch a graph just based on a few pieces of information. Alright, so let me get rid of that. It's in the video, but it's not going to be in your notes. No, it does that. Okay. So now that we know this, let's practice by first finding these. By the way, guys, just so you know, I forgot to mention this. A turning point is also known as a stationary point. So let's take a note of that. Note. A turning point is also known as a stationary point.
We're going to have to find this point A.
Yes, it's easy, don't worry. Which stationary is this? That's A, yeah, this one's A. As a stationary point. Okay, to find a stationary point, let dy dx equal 0 and solve for x. That's pretty much the process to finding a stationary point. Now, I'm going to give you guys a few examples and we're going to find stationary points now. By the way, guys, I'm going to use the easiest turning point you guys can find at the moment. You guys know how to find the turning point of parabola, right?
Yeah.
That's called a vertex. I'm going to use calculus to help you find the vertex as well. So watch, you're going to see the same thing happen. We know that to find the turning point of a parabola, we use x equals negative b on 2a, correct? But we can also use calculus too. Okay? So, find the turning point of, what is it, of y equals to 3x squared minus 2x plus 5, and determine its nature. Okay. Whether it's a maximum or minimum. When a question says nature, it's talking about if it's a maximum or a minimum. So now, again, dy dx equals 0. So this is step 1. Sorry, not equals 0. Step 1, you just differentiate. Dy dx is equal to 6x minus 2. Okay? Now, step 2, let dy dx equal 0 for stationary point. Okay, so we let dy dx equal 0. And we end up with 6x minus 2 is equal to 0. We solve this, and we get 1 over 3. Now, guys, is this a point? No. A point needs x and
Why?
y. Where do I get my y from?
You sub it back into
To where?
the equation.
FX, the original.
What's the equation?
Why?
Yes, you always go back to the original for a point. You don't go to dy dx. Dy dx is for functions. So sub x equals 1 on 3 into y, not dy dx. So y is equal to 3, 1 over 3 squared, minus 2, 1 over 3, plus 5. Can someone put that in the calculator? The other.
So it's 14 on 3.
14 on 3. Alright, there we go. So we've got 14 on 3. Therefore, my turning point is 1 on 3, 14 on 3. But I haven't classified what kind of turning point it is yet. Okay? Now we've got a third step. So step 3. This is a new step, guys, so pay attention. Huh? No. That's the other method. I'm not going to teach that till second derivative. Now, step 3. Use the box method. Mohammed, that's recorded. Use the box method to determine... He didn't even realize he swore as well. Use the box method to determine the nature of the turning point. Yeah, you did. Of the turning point. No, he said the... I'm not going to say it. Yeah, that word. Alright, so... we're going to use this to find it. Now, guys, what you do a table of values. You do a table of values for x and dy dx. Not y. You have to use x and dy dx. There is an easy way, but you'll learn that in second derivative. But this is also important, so I'm not going to even go near the other method right now. Okay, now what happens is, I don't think I can do partial rubbing out. No, it rubs out the whole thing. Alright.
Yeah.
Okay, now guys, this is very important. Pay attention. What I need to do here, what was my stationary value? The x value. 1 over 3 right here. Now guys, what I need to do is I need to choose a number above 1 over 3 and below 1 over 3.
1.
Very good, who said 1, 0? You think like me. Now, the way we can do it, usually some teachers, they recommend going up by small increments. But you only do that if you have overlaps of turning points. So for example, guys, if I have turning points at 1 over 3 and 2 over 3, would it be advisable to test 1? No, because 1 over 3, if I use 1, it jumps over 2 over 3. So I might have a turning point like this, right? 1 over 3, 2 over 3. And I want to test this one. But I jump over here to test it. You get me? It'll stuff it up for me. So unless I have close numbers, I will then use small increments. But right now, because there's only one turning point, I'm going to use 1 and 0. Now, guys, what was the dy dx value for 1 over 3? It was 0. Very good. Because I let dy dx equal 0.
And minus 1.
Make sense? Now what I do, I figure out 0 and 1 from dy dx. So dy dx is 6x minus 2. So we're going to sub in 1 into there. 6 times 1, take away 2. What's that?
4.
Positive.
Now sub in 0. 6 times 0,
1, 2.
and then negative 2. You have negative 2. Watch this, guys. Negative gradient. Which way does it look?
Down that way.
There. 0 gradient. Flat. 4. Which gradient?
Oh.
Ah, what kind of turning point is that?
Minimum.
Minimum turning point. Therefore, I can say that 1 over 3 and 14 on 3 is a minimum turning point.
Because when it's smallest, because stuff from left to right here,
Feels nice where you went.
it's gone that way. It's gone
Did that make sense, guys? I better fix that. Okay, so 1 over 3, 14 over 3 is a minimum turning point.
Because if it's decreasing.
Now, when I sketch this, I didn't ask for it to be sketched,
So,
but yeah.
how would you know that they're going down like that?
What do you mean?
How do you know it was like this, like that, and that?
What's a negative gradient look like?
Downward.
Oh yeah, that's right.
Negative gradients are all like that. Positive gradients are all like that. Got it? And 0 gradients are always like that. Okay, so let's sketch this. I didn't ask to sketch it, but just so you guys get a deeper understanding, we will sketch it. Now look at this. The turning point, the vertex is right there. Or actually in this case it's the turning point. So 1 over 3, 14 on 3. Okay. Now I can also see that the y-intercept is 5. See that? It's 5. So what's going to happen? It's going to do this. And since there's only one turning point and it's concave up and it's a minimum turning point, that's what I get. And that there is 5. Do you notice this also, it also helped me not to find an x-intercept? Because if it's above the x-axis and it was concave up, it just worked out like that. Now if I use the traditional 2-unit method, x equals minus b on 2a, watch this. You will sub in negative of negative 2 over 2 times 3. Look at this. You get positive 1 over 3. Yes? And when you sub in the y value, you get 14 on 3. So look at that. Same turning point. You know how to do it this way. Now you know how to use a calculus way.
No, we still use it that way.
But like I'm saying, for parabolas, don't you dare use calculus. Very silly.
Yeah.
Very silly.
What's taking what?
Might take a while. It took 3 steps. Okay?
And what time do you go?
In a few minutes.
Didn't you say the prime here?
Okay, so
It's a bit-
what are we gonna do? I think shall we do one more example?
Yeah. Yes, sir. One more.
Yeah, let's do one more example. Where do you need to go?
So we're praying here anyway.
You said that, yeah.
Crawling out.
Now, wait.
Are you fast
Me. Boys and girls, let's just do this. I'll do it quickly, don't worry. Okay, so now find the turning points of y equals to x cubed minus 3x squared. So what's that? 3x squared minus 6x plus 5x minus 4. Alright, find the turning points and determine their nature. Alright, so watch this, guys. So I'm going to go through the same steps I did earlier. So step 1 was to differentiate. So dy dx,
3x squared
3x squared
6x
minus 6x.
plus 4.
Okay, I think I chose a bad number. Hold on. Negative 6. Let me use 9. Huh? I don't know.
Mathematicians. Mathemagic.
I might not be right. I'm still not sure.
Oh, there's gonna be a lot of scribbling. Yeah, hey.
Okay, so now dy dx. There's gonna be lots of dy dx is that. Now look at this. Step 2. Let dy dx equal 0 for a stationary point. Guys, I'm drilling this into your heads now. HSC, you must absolutely write this line.
dy dx equals 0.
For stationary point, you must write this.
Because the HT might not know what you're doing.
You have to write this line. So we end up with 3x squared minus 6x plus 9 equals to 0. I can divide everything by 3 now. Why? Because it's equal to 0. So x squared minus 2x plus 3. And I did stuff up.
Again.
Okay, just liquid tape and just put 1.
Oh, yeah, liquid tape. Inshallah, I have that.
There. 1 is good. 1 is good.
I don't know.
Oh, no, it's not. Don't do 1 either.
I didn't write it.
Do 3. 3. 3. Do 3. Don't worry, my blooper will be on the video as well, so it's alright. My reputation's up for
Seriously,
up on
John,
the
yeah,
thing.
good on you.
So about, is that only us in the English scene yet? What?
Alright, guys. Now, watch this. I've got x squared minus 2x plus 1 equals to 0. And I know how to factorize this, so you get x minus 1 squared. And look at that. You get x equals 1. So I only ended up with 1 turning point. I only ended up with 1 turning point here, guys. So now, no, this actually makes it harder. Now, watch this. Get the y value straight away. So y is equal to 1 minus 3 minus 2 plus 3 is 1 minus 4 is negative 3. So that's the point. So 1, negative 3. Remember, where do I get this y value from? In there. Okay? Remember, points always in the original. Now, from here, I need to determine its nature. So we use the box method. Yep. So we put 1 here. There's only 1 turning point, right?
Yeah.
So I can jump to 2 and 0. Make sure you put a 0 here.
So where'd you get negative 3 from?
In my head.
So where'd you find 2?
Oh, here. I subbed in x is 1 into here.
0, 0.
Remember? Because it's a point. You go back to the original.
You know, you're just using them as
Now,
points as
I'm going to
parts of
sub
the
in
actual
0
point.
into dy dx. So we get 3. And now I'm going to sub in 2 into dy dx. So we get 3 times 2 squared is 12. Minus 12.
Right.
And we get 3 again. Now, this is what I meant. And you know what? I'm going to leave this on a cliffhanger for next lesson.
What do you mean?
Because, look at this.
Is this,
It's cubic.
I got a kink here. Those of you in 3 in it know what I'm talking about. But that's what happened in this case. We'll leave it at that, guys, because I did not expect that to happen. So that's a whole other topic. Alright, so basically what we did yesterday, we were observing the nature of turning points and how you can identify these turning points through the box method, okay? And as you can see here in the example, we had the turning point and we verified it through here. How do you verify it? It's by the signs of the values that you get. You see how that's negative? Hence a negative gradient. You see how that's 0? 0 is the one that you solve for, so regardless you should get a 0. And over here, you can see we got a positive number, so we just assume a positive gradient. You don't have to be specific. You don't have to say, oh, because 4 is like this, I have to draw it like that, and because negative 2 is like that, I have to draw a bit shallow. It doesn't matter. I'm only concerned about this and what's in front of it. Okay? Once you figure those out, you'll be able to determine whether it's a minimum turning point or it's a maximum turning point. Okay? Now, when we came down to our problem yesterday, though, we encountered a strange situation. Now, unfortunately, we encountered it too early. I did not want to encounter it in my second example, but it happened, and we can still figure out what's going on here. Okay? Those of you in 3 unit, you recognize this straight away as something. Okay? Now, the rest of you, You should slightly recognize it too, but it's not as obvious, okay? It is definitely a cubic graph, so that's what I need you guys to identify. It's definitely a cubic graph. Now, we found the point where it kinks, all right? And it's telling us that at this point, we get this shape happening, all right? But this is more related to the next topic of calculus, which is called points of inflection, okay? So I'll just mention it now, but I won't go into too much detail. But even using the box method, I can sketch this graph. Okay. What is it? But it's not. Look, it goes like that, flat, that. You see it's a clear kink? It's a clear kink. You're actually following the gradients, but in a curved sense. All right, so let me just quickly draw this graph for you because we don't have too much information. Y, X, and what we can see here, we have 1, -3, down here. We have 1, -3. Now, the nature of the graph, it tells us it goes like this, and then like that. So that's what I'm going to do. Another thing I can also identify, guys, is remember that the constant is what? What's this? This is the y-intercept, isn't it? Yes? So I know that the graph is going to intercept at -4 right here. And then I know that it's going to go up here like that. Now, do you also see there's an x-intercept? Unfortunately, in this case, this question is too hard to factorize. So we're not going to bother with it. You don't have to actually find the x-intercept all the time in 2 minutes. Okay? You just have to get me the basic shape. Now, does the shape make sense in regards to the nature of the turning or the nature of the stationary point? Yes. Okay. We want to find... We want to find the stationary point. For y equals 2x cubed minus 3x squared minus 36x plus 2. Yeah, I know. So it's question 5c that I want to do. Okay, it talks about finding a stationary point and determine whether it's a maximum or minimum. So that's what we're going to do. We're just going to find the stationary points and then determine its nature. And hence determine the nature. So do we all understand what determining the nature means now? What does it mean? That's it. Just whether it's a maximum or a minimum. That's all it means. Okay. So let's move beyond with some differentiation. So I'm going to differentiate that. Okay. So who wants to help me? So let's differentiate this now. So dy dx is equal to 6x squared minus 6x minus 36. Okay, so nice simple differentiation. Now, what is the rule for stationary points, guys? What must I do? Very good. And what must I write? For stationary values. You have to write this sentence. For stationary values. If you look at any HSC Excel Success 1 2-unit textbook, you will find in the solution that they'll always write something like this line. So let dy dx equal 0 for stationary values. Okay, so we end up with 6x squared minus 6x minus 36 being equal to 0. Now, as you can see, there's a common factor of 6 for every term, and the equation is equal to, so I can divide everything by 6. And I don't need to fuss over it, okay? I cannot divide here by 6, because if I do, I have to put 1 over 6 here. Like that, I have to do that. But because it's equal to 0, what's 0 divided by 6? Exactly, so I can go 6 and put a 6 here, it doesn't matter. Okay? So now we end up with x squared minus x minus 6 is equal to 0. And that's a simple quadratic equation. You can factorize it. If you don't know how to factorize, use the quadratic formula like I did yesterday in that example. But this one's quite simple. You go x minus 3, x plus 2 equal to 0. So now we've got our two values. So therefore, x equals 3 and x equals negative 2. Yeah, so first thing you should do, guys, always find the y value straight away. Just do it. Okay? Can someone sub in x equals 3 into this equation? Remember, a point goes into the original. Negative 79? Okay. And someone do negative 2, please. 46 on the ball. Now, my intuition tells me this is a minimum. That's a maximum. But you must prove it. Why do you think I've said this is a minimum, that's a maximum? Look here. Isn't that point lower than that point? Think about it. 3, 70, negative 79 is down here. Is it negative 79 down here? And then negative 2, 46 will be up here somewhere. My intuition tells me that's how it's going to be. So let your intuition guide you in the question as well, guys. This is how you'll know that you're correct. I haven't done anything yet. I'm just saying. Oh yeah, in the original. They always go into the original. But you see that I want to predict what I'm going to get as well. That's what helps you to determine that you're going to be correct. Alright, you know how sometimes teachers tell you in maths you can check your answers? That's how I check it in this case. Alright, now let's do a box method. So we're going to do box method for both, for which values, guys? Yes, so we'll do a box method for both x equals 3 and x equals negative 2. What is dy dx at 3 and negative 2? Very good. Okay, so now we'll do our box dy dx. Alright, so I'll start with these. Now watch this. I just put a little break here because I'm lazy, and I will put negative 2 here, and then I'll start with 3's test over here. Put a 3 here. Okay, and then I will determine my values beyond that. We know that here and here is going to be 0. Okay, now guys, tell me a value to put in here. Negative 3. Very good. Tell me a value to put in here. Negative 1. But 0, honestly, 0 is a good choice. Why? It's very easy to sub in. But yeah, you can use negative 1, but I'm going to go with what Zach said. Does 0 overlap the 3? No, so I will definitely use 0. And here's another thing. When I'm testing 3, I can also use 0. Because that does not overlap with minus 2. It does not overlap with it. Okay? Like for example, watch this. If I test 4, I've exceeded that value. You understand? I must stay between negative 2 and 3. So long as I stay between, I can choose any number. And I prefer to choose easy numbers. So I will choose 0, 0, and 4. Okay? You can choose any numbers, but I prefer to choose easy numbers. Now, can someone please sub in negative 3 into dy dx? So negative 3 into this one. Someone do that, please. Yeah? 6. And then look at this. I will sub in 0 into here. I don't need a calculator because it's just negative 36. Because those two will disappear. Okay? See how quickly 0 works for us? So that's going to be negative 36. And look at this. It tells me exactly what kind of turning point it is. At negative 2, we have a positive, a 0, a negative. So didn't I say that's going to be a max? Wait. Sorry, wrong one. Didn't I say that's going to be a max? Yes, I did. Now let's try it with the other one. So we already tested 0. 0 is negative 36. And then someone test 4. 6 again. 36 this one? This one's 36? Yeah? Okay. Well, there you go. Did the signs change again? Did the signs change from here to here? Yes, they did. So this is a negative gradient, 0 gradient, positive gradient. And look at that. Can you see clearly how it works, guys? This is a max. That's a min. So therefore, we can say, negative 246 is a maximum turning point. Yeah. It's 36? Okay. So that's 36. Okay. Yeah, because of symmetry, the values come out the same. Yeah. Alright, and because, look, I only moved one space there. Yeah, it's because it's symmetrical, you get the same values. Alright, negative 246 is a maximum turning point, and 3, negative 79, because I got 3 here, see that? Is a minimum turning point. I like writing minimum. This looks like a bunch of scribbles. Okay, so we happy with that? Yeah? Now look at this. I just need to know a few key features. This part here, that's my y-intercept. We all know that by now, yes? The constant in the original equation is always the y-intercept. So what we'll do, I'll just take note of that. Oops. That's the y-intercept. Okay. And now we can sketch it. Doesn't have to be to scale. But at least have some sort of accuracy in your sketch. Now we have 3, negative 79, so we'll assume that's all the way down here somewhere. And then we have 2, negative 2, 46, so we'll say that's somewhere up here. So negative 2, 46. So long as you show me these key features, guys, you will get full marks for your problem. Okay? So what do we say 3, negative 79 is? A minimum. Yeah, look at that. Just draw a little smiley face to start. What do we say negative 246 is? It's a maximum. So draw a little sad face. Okay, and we can see that the y-intercept is 2. So it's going to cut above the x-axis somewhere like that. How's that? Now, I'll explain that in a second to you. There we go. Now, do you think it'll be easy to find these points by looking at that? Perhaps only the 3NET students can find it. You remember the method I showed you in polynomials? But it's not needed to you. So, guys, I'm going to start by looking for the derivative. So, dy dx equals to 16x cubed minus 4x. Now, to find a stationary value, we let dy dx equal 0. And we end up with, right, gotta write this. Alright, so we end up with 16x cubed minus 4x equals to 0. Now, this is a common factor that we got to start with, so 4x squared minus 1 inside the brackets. And I can solve from here if I want to. I end up with x is equal to 0, and 4x squared equals 1, x squared equals a quarter, and therefore x equals plus minus a half. Okay, so I've got 3 values there. Now, what I'm going to do, I'm just going to get their y values. So y equals to 0 here, when you sub it in to the original. So subbing into there, you put 0 and 0, you get 0. Now for half and negative half, one thing I took note is that this is actually an even function. You do not need to prove it's an even function, but if you remember the rules, you can use tricks just to speed up your process. So I know that if I sub in half, the y value will be the same for both half and negative half. That's a rule. Remember when we did the sketching for even functions and I said complete the other half? The y values had to be exactly the same? Yes. Okay. So all I'll do is I'll sub in half. Alright, so what do we get when we sub in half, guys? Negative a quarter. So they both have negative a quarter. Okay? Now what I'm going to do, I'm going to do the box method. Because I want to check the stationary values and their nature. So x dy dx, it's the same. I said that. It's an even function. Then you did something wrong. It should be negative a quarter. Reason being, didn't I say it's an even function? When you have, say, x is equal to a, it will share the same y value as x is equal to negative a. Okay, that's one of the rules of even functions. So now from here, just do my box method. I might have to compress it a bit. Now, guys, the reason I like to do it like this is because it makes me aware of the order of the numbers, and it will help me to prevent overlapping. I find when people do separate boxes that they make the mistake of overlapping. No, redo. Alright, so I don't want to overlap. All right, watch this, guys. Negative half was the smallest x value I found, right? 0 is the next in line, and then half is the next in line. And with these dy dx values, we found it by putting in 0. Now, guys, when I choose my numbers, between the turning points, I must choose values between negative half and 0. So give me a number between negative half and 0. Negative what? 0.1. Okay? And because it's between negative half and 0, I will use it again here. Alright? And then over here, give me a number between 0 and the half. 0.1 and 0.1. Okay? And then these ones I can just choose 1 and negative 1. Alright, so let me just finish this, guys. Yeah, but it's not overlapping. It can't overlap in this section. It only works in order. You can't overlap within the turning point sections. Alright, so guys, what do we get for negative 1? Negative 12. Did anyone do negative 0.1? Girls, did you do it? What did you 0 point? 0.4. 0.4. What about 0.1? Negative 0.4. And positive 1? Alright, excellent. Now watch this, guys. We get negative, 0, positive. Look here, positive, 0, negative. Look here, negative, 0, positive. I can figure out what each one is. This is a minimum, maximum, and minimum. And just real quickly, this is not part of the exercise, but this will make next lesson 10 times easier. Not yet, but next lesson, 100% you will. But that's what I'm saying. It makes next lesson much easier for us. So when I sketch this, now watch this. We have the points 0, 0. We have half and negative a quarter. So half, negative a quarter. I'm going to exaggerate it, obviously. And then we have negative half, negative a quarter, which is the same thing here. We can see that 0, 0. Look here, 0, 0 was a max. And then negative half, we had a minimum. And then over here, we had a minimum as well. And look how it connects. 1 second, Shady. And look at that. You get a W, guys. Did we not also say that this is an even function? And there you go, guys. Make sure you also write the value of the turning points on the graph. And that's that. Okay, guys? The homework is the same as yesterday, so I'll just leave it at that for now. Next lesson, we're doing curve sketching, and we're going to expand upon this even further. Okay, so we're going to do the curve sketching checklist. Now, the first thing, any suggestions as to what you think should be our first check? What's the first check we should always do, guys? Well, yeah, the intercepts are the easiest. What's the easiest? The y-intercept. You just sub in x equals 0. All right. Find the y-intercept. All right, that just means you let x equal 0. Okay. What do you think number 2 is? Huh? Now, with this one, you got to be. You have to be wary. Remember, I gave you guys a rule or a stipulation yesterday. Remember, find the x-intercepts. I'll put it in brackets because sometimes there's only one intercept. But there's a catch, guys. Alright? The catch will be only if possible. You remember how we had a cubic? Yeah. Who did I say can only find the roots for a cubic? Not, like, some questions, only 3 and 4 students are going to be able to find it. Okay? With Tuna, they don't have a technique for you guys to find it. Okay? Except for just guess and check. Okay, so that's the second step you want to take. The third step, what do you think, Hazel? Differentiate. Yes, that's right. So you get the gradient function. Differentiate to get the gradient function. And with this, you're actually finding dy dx. All right, the next step. You will find the stationary values. Now, there's another catch here, guys. If possible. Okay, the reason you can't always find it, like some curves, they're like, for example, powers of even powered curves. Sometimes what they do, they have a derivative function, but they might only have like one stationary point, or a cubic. It just has this thing. Where's the turning point? You get me? There's no turning point in the cubic. Remember we did that question the other day? There's no turning point. There is a stationary value, but it's irregular. It's not normal. Okay, so these are the sorts of things you got to deal with. Maybe, if possible, is not the right thing to say here. So I'll just leave it out. But just basically, you have to find the stationary values, if possible. Just scribble it out. Now, in this case, you would let dy dx equal to 0. Okay? Next step. Yeah, but I'm being very specific here because I don't want you guys to miss a beat. It's not this hard. You guys already did it. You guys have actually already done curve sketching. But I'm giving you something that you always need to have. This is your checklist. Okay? So now, find the stationary values, y values. Remember that step? That's right. And this is possessive, so I've got to put an apostrophe there. So find the stationary values, y values. Okay? Sub into original equation. Yeah, y. Y. You know, like y equals. Sub into original equation. Next step. So we've done that. Okay, here. This is the key step. This is the new thing you learned yesterday, guys. Use the box method to determine the nature of your stationary values. So stationary values. Now, basically, just I'll write a little thing here to remind you guys how that works. If you have x dy dx I'm just going to say x1. I'm going to say x1 and a little bit bigger. And I'm going to say x1 and a little bit smaller. So I'm surrounding it around x1. Okay, that's pretty much what I'm saying. This is your stationary value. Okay, now if it's greater than 0 and less than 0, that's how it has to be. Okay, so this would be greater than 0, negative. What kind of turning point is that one? Maximum. This one's a max.
Last time I was not like that. And then you said we'll go back to our next lesson.
Didn't I deal with it? No. I thought we did. Yeah, we did.
Yeah, we did it. Oh.
We did it.
Then you have to go for it.
The purple one. Yeah, we did it. All good. Alright, so that's a maximum. That's what a maximum table will look like. Let's do the minimum table. So you get x dy dx this is x2. You choose a number a little bit bigger than x2. You choose a number a little bit smaller than x2. Just make sure they don't overlap. The center is always 0. This will be less than 0. That'll be greater than 0. And if we check its gradients, less than 0, meaning a negative number, that will look like that. 0, and then positive. Sure. Alright, now this kind of turning point, this will be a minimum turning point. Okay? And you all can see that clearly. We all good? Focus, guys. We all good?
Yeah.
Alright, that's your checklist up to here. We've done y-intercept, x-intercept, gradients, stationary values, box method. You have everything. Last thing, plot the critical points and connect the dots. To sketch your curve. And that's that. Did we not do this, guys? We already did this whole checklist. It looks complicated like this, doesn't it? But you guys did it yourself. How simple was it? Someone let him in, please. It's very simple. So let's try a question ourselves now. Let me load up a problem here. Where are we at? Oh, wait. All right. $11.7. All right. All right, guys. 11.7 here. Who wants to choose a question? Someone just choose.
6, 8, 2, 5.
Yeah,
What? Dude.
We did one like 6, didn't we?
Alright, 7.
Nine.
We did one like 8 as well.
We're the same.
Nine.
2, 6, 4.
Five.
We're like 4.
7. Three. 1, 2, 3, 4, 5, 6.
Let's try 7.
Say.
All right, we're gonna sketch 7.
Interesting.
So, sketch.
Discussion, guys.
What is it? Someone needs something? Oh yeah. Let me just write the question first, and then we'll go to it. Sketch y equals 2x cubed minus 9x squared plus 12, showing all stationary values and critical values. Yep. Is that up? Yeah, I think it is. Yeah. All right. Yeah. Anyway, I don't know. All right, so because we've got a bit of experience, I'm actually gonna go out on a limb and let you guys just try and follow your checklist. Okay. All right. First things first. Let's follow the steps. Find the y-intercept. Let x equal 0. So y-intercept. I'm not even going to let it equal 0. Remember I said the constant is always the y-intercept. So y-intercept equals 12. Second step, x-intercept's not possible. I'm not going to do it. Okay? It is possible, but I don't want to do it in 2 unit. The step 3, differentiate to get the gradient function. So dy dx equals 6x squared minus 18x. Yep, and just close the door behind us. That's 6x squared, take away 18x. Now, the third step, the fourth step, find the stationary value. So we let dy dx equal 0. Now, do you remember what I said here? What must you write? You have to write this. You must absolutely write this. Who didn't write it? Alright, you lost the mark. Just so you know. Let dy dx equal 0 for stationary value. It's a strange rule, but you have to do it. You take note of that. It's a very strange rule, but you must absolutely write this sentence. Did you write dy dx equals 0 stationary value?
Yeah.
That's fine.
I didn't write stationary values.
No, you have to write stationary values. You have to write it. Okay. Girls, come on. I'm not done. Let me finish this. So let dy dx equal 0 for stationary values. And now we're going to solve for it. So 6x squared minus 18x equals 0. There's a common factor of 6x. And we end up with x equals 0 or x equals 3. Look at the next step. It says find the stationary values, y values. So we sub it into the original. And if this one, do you notice this one is the same as the y-intercept? So that means there's a turning point on the y-intercept. You can have doubling up here. Okay? And then we hit, what do we have here? We had negative 15 if I remember correctly. Alright, so y equals negative 15. Alright, so far so good? Alright, let me open up the box method now because that's step 6. We shall use the box method. So x dy dx. Now remember, I like to do the box in one go. And I just like to create a break here in the middle. Okay, it keeps your numbers in check so you don't make a mistake. All right, and then we start from smallest number to biggest number. What's the smallest number out of our stationary values? 0. So I'll put 0 here and I'll put 3 here. Always go in order. Because remember that question we did last time? We had negative half, 0, half. You have to make sure you don't overlap. In this case, the numbers are nice and spread out. We have 0 and 3. I can definitely choose 1 and 1 for both. All right, I'm going to choose, 4 and negative 1 here. So here, remember, for the stationary values, you did get 0. You found it through 0. Okay? With 1 was 12? Negative 12? So that's negative 12. Look at that. Because I can use the same number, I can write it twice. I don't have to think. Does it? Okay, it's just about gradients. But negative 1 is positive 12, right? Or is it 24? 24. What was 4? 24. Okay, so there we go. I can determine now this is positive, 0, negative, negative, 0, positive. So I can figure out that this is a maximum turning point and that's a minimum turning point. So that tells me that 0, 0 is a max. 0, 12. This one here. That's a max turning point. Okay? And this one here is a minimum turning point. Alright, that is all the information I need. I can now sketch it. Guys, just be patient. I'm just going to sketch it and then we can go. So we get our y-axis, our x-axis. Let's plot our points now. I will make a pink graph. Alright, so we had 0, 12. So that's 0, 12. Guys, focus. And 3, negative 15. So somewhere down here. Now, at 0, 12, we had a maximum. So just draw a quick sad face here. And at 3, negative 15, just draw a quick smiley face here. And then connect the dots.
So this is book 1.
Book 1, chapter 11. Alright, and that's it. Easy? We pretty much did all this yesterday. But now we have a list to make sure we don't miss out anything. All good? Alright, I'll see you all next lesson. You can review chapter 11.6. I think it's 0.6. If not, it's 0.7. I'll see you all next lesson.